The third learning objective in section 5.4 is to calculate and interpret the probability of a compound event using the addition rule. Data submitted to the U.S. Department of Transportation showing the on-time and delayed flights for Alaska Airlines for several cities are given in the table below. Part 1. What is the probability that a randomly selected flight is on time in Phoenix? So, to be on time in Phoenix means the flight is one of these 221 that are in the on-time column and the Phoenix row. So the probability that a randomly selected flight is on time in Phoenix is 221 out of the total, which is 3775. And we can do that actual calculation in GeoGebra. 221 divided by 3775 gives us 0.059. Let's round to 3 decimal places. Okay, next example. What is the probability that a randomly selected flight is in Phoenix or on time? This keyword "or" tells us that we're going to use the addition rule. Here's the general addition rule. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so if we want the probability of being in Phoenix or on time, Phoenix will be our A, our first event, and on time will be our second event. So we will look at the probability of being in Phoenix. There were 233 total flights that were in Phoenix. That's the total for the Phoenix row. Then we will add to that the probability of being on time. So there were 3274 total flights that were on time. That's the total of the on time column, again divided by 3775. And then we will subtract the probability of being both in Phoenix and on time, which is the 221 out of 3,775 that we calculated in part 1. All right, so we can do this calculation in GeoGebra as well. 233 divided by 3775 plus 3274 divided by 3775, and then minus 221 divided by 3,775. And let's write that as a decimal. We get 0.870. Let me explain why we do that subtraction like we did. The 233 comes from 221 plus 12. The 3274 comes from 497 plus 221 plus 212 plus 503 plus 1841. So you'll notice that 221 got included both in the Phoenix row and in the on-time column. And so those 221 flights got included twice when we added the two probabilities together. So we have to subtract them off once in order to make sure that they are not double counted. Okay, one more part. What is the probability that a randomly selected flight is in Phoenix or San Diego? So Phoenix includes the 233 individuals here, or flights, and San Diego includes these 232 flights. And notice that there are no flights that can be both in Phoenix and San Diego. Using our addition rule up here, we can compute the probability of Phoenix plus the probability of San Diego, but there is no probability of being in both Phoenix and San Diego because it would be 0 out of 3,775. So we can just take the 233 out of 3775 and add to it the 232 for San Diego out of 3775. And then we don't have to subtract anything because Phoenix and San Diego are disjoint, so they don't have any outcomes in common. So 233 divided by 3775 plus 232 divided by 3,775, and that gives us, convert it to a decimal, 0.123. Rounded to 3 decimal places.